Thanks, Julian. So I've been asked to talk about data and modernizing agronomy. And I'm lucky that I have the role within Agrible, which is a startup here in town, as CEO, to take a bigger picture view of some of these things. And to start off, I wanted to tell the story of a Model T or a UFO. And I have, for some of those who know me, a car hobby. And these are not nice cars. These are old junky pieces of garbage, that my wife would rather me not have. The example here is a 1915 Model T, and this is actually a picture of the research park. I drive this thing, well, not on weeks like this, but during the summer I drive it once or twice a week. It's 100 years old, and I park it in the parking lot, and it looks as odd sitting next to a modern pickup truck and some of the other cars as a UFO. And you have to think about that and say, well, I respect, and the reason I have a Model T is Henry Ford as one of my role models in my life, and he's said things, very interesting things about technology, and when the cars came out in like a 1915 Model T, when that car was first arriving, that if I asked people what they wanted, they would have said faster horses. We kind of say, wow, that sounds great. That sounds really interesting. Yeah, go for it, Henry. And you hear the same thing from Steve Jobs and others, that you can come into an industry and maybe people don't know what they want. But that's setting aside for the fact that cars were around since 1903, and Henry comes on the scene with his Model T. People already know cars, they're just too expensive. He's figuring out a way to bring it to people, lower the cost, figure out that mass production, and there's just elegance in the design of this vehicle. I don't maintain this thing very well. It's 100 years old and I drive it to work. It does what a modern car does. Now, can I take it down the highway? No. Do I have to go like this and like this and like this for turn signals as I'm driving it? Yes. Can I drive it at night? No. There are limitations to what Henry's vision was 100 years ago, what the automobile would be, what it is today. But there are parallels to that, I think, in ag tech. And as out of place, we find sometimes bringing software to folks and saying, well, where are we? Can we work with the Model Ts? Can we work with the modern cars? Can we integrate some of the UFO technology together into agriculture? And I think absolutely the answer is yes. And our job as scientists and engineers in that space is to make it straightforward, make it simple, make that user experience clean, so that it just becomes something that people adopt and grow to love. So thinking about modernizing agronomy and thinking back to just my viewpoint, and this is from my perspective of the history of agronomy and agronomic research and the application of that through agricultural engineering. 1920 to 1970, basic research, the creation of many of the models that underwrite and are beneath the technologies that we use today. In 1970 to 1990, you have computerization of research, the taking of these models and starting to run them on punch cards all the way up through the different systems that I worked on through the 90s. We added a spatial component, the GIS, the Geographic Information Systems part, that took those models and then made them spatial, and that's what we're talking about with precision ag now so frequently. And then in the 2000s to 2010, we merged that code base with a GIS and started to see some of those integrated systems. Then 2010 to present, statistics is rebranded as big data. It's always been there in the fields of atmospheric science and research. We've rebranded as big data. What does that mean? We hear groups like the American Society of Agronomy, ASA, have a whole group that gets together to talk about big data. What does it mean? What does it mean to agronomists? What does it mean to research in agronomy? Then we talk about meta-analysis, of pulling all these studies together and jamming research into big data. We have to be careful of that garbage in, garbage out attitude, where a researcher would know the nuance of the data set. And agriculture is nuanced from any viewpoint, from the perspective of the grower, from the perspective of the researcher. It's so local, it's so focused. There are techniques and changes and cultural practices and things that vary across a region and county by county. So when we're talking about modernizing agronomy, we have to think about the history, where things have been, and then kind of a call to action here into the future, where we are at a point now of talking about big data and this grouping of things together, but we're leveraging technology that's 50 years old. And I think there's actually a call to action here within the research community to come back to some of the basic field research and field experimentation. I know this is needed because I have to go out and do this. Part of what Agrible has to do is go out and build data sets to power the analytics that we're building, because they simply don't exist. The movement of science, the movement of technology, what's cool, what's interesting, what's been funded at universities has driven us away from some of that basic field research. So Agrible, a holistic ensemble approach to data and science. We often think, is it grandpa versus big data? And is that a generational thing? Perhaps. Grandpa has institutional knowledge of what's going on a farm. Big data is another approach. It's statistics, it's analysis, it's all the smart people working off the farm, pulling it together and coming up with some kind of technology that could maybe help a grower. But it's not big data alone. Big data alone can't fix things. Big data really is an ability to look at information that's out there, things that have been collected, and trying to predict the future. We have a philosophy at Agrible that every field and every year is an exception. You've never seen it before, you'll never see it again. Well, it's very hard to go to a data set or to grandpa's knowledge and predict what may happen coming out of an El Nino into 2016. What's that going to do? Can we look to the past? There was a similar condition in 1997. Can we go to 1997 and pattern it and say, well, 2016 will be just like 97? A data scientist may say that with a big data approach. Modeling approach may say otherwise. We rely with Agrible really on qualitative information, that's the grandpa piece, a quantitative analysis of modeling. There's theory behind and observation. It's just science. It's not big data, it's not grandpa, it's just science. And that's really the ensemble approach and an approach to modernizing agronomy. And I'll end with just an example of kind of an application of that. This is a screenshot out of Morning Farm Report, our lead kind of product out of Agrible. And what I'm showing here is a product called Spray Smart that in a day, a grower's out in the field trying to make an application of a herbicide or a pesticide, insecticide, fungicide. This hour by hour goes through and talks about the ground conditions. Can you drive in the field? Is there an inversion? There's changes in the marketplace right now with Roundup resistance and tolerance and dicamba and 2,4-D reemerging as major use compounds. Inversions are important to grandma's rose bushes, a neighboring field, an organic field. We have to think about these things. Wind speed, directions, conditions. We see all this stuff. It's all out there. You have an app on your phone that tells you the wind speed. We'll tie it together, give it an agricultural context, pull it together for growers. That's modernizing agronomy. And last, we have a pollinator piece, and this is really the new science, emerging science, where we can take an indicator species like a honeybee, predict when they're going to be out traveling, hour by hour through a day, and give that grower some knowledge right there in the moment of, should I spray early in the morning? There's a higher risk to a pollinator community if I do. If I wait here until 10 a.m. or 11 a.m., I can actually get into that field, minimize my risk to a pollinator, and still get my work done before I have a rainstorm that hits later in the day. So that's the sort of things that I wanted to just alert you to that were coming. It's that merger of data technology, putting it all there right in front of you, right in front of the grower, interacting with them, and that's the opportunity for us.